Hello, everyone. This is a functional programming meetup, and it's a kind of continuation for our introduction to functional programming class. And today, Pietro Loffredi is going to present F Sharp, learning F Sharp and functional programming for fun. So the floor is yours, Pietro.
Okay, thank you. Um, the first thing I want to highlight is my presentation is heavily inspired by the material by Scott Olaskin. The website is F Sharp for Fun and Profit, and this is my source of truth when I want to learn something about F Sharp. And there you can find. Great material to understand how to do domain design with F Sharp. And I think it's pretty interesting. Okay, first of all, the language evolution. The language evolution of F Sharp during the years. The first appearance of F Sharp with version 1.0 in 2005. The F Sharp was released with version 1.0 in 2005 and was developed in Microsoft Research in Cambridge, UK, by a language designer, Don Syme. Essentially is a .NET implementation of OCaml, and the aim of the language is to combine the power of a functional language with the incredible amount of libraries already present in the .NET ecosystem. It was open sourced with a Apache license, so a very permissive license, and at the time was only compatible with Windows. In 2010, it was released the version 2002.0. That for me it was like a big leap in the language, because added the support for Mac OS X, Linux platforms, and other platforms, and it was the only functional language present in the .NET ecosystem that could be used in different platforms. F Sharp 3.0 in 2012 introduced another. It was another leap in the language evolution, because introduced JavaScript and GPU as supported platforms. This led the creation of several projects that not that wasn't necessarily related to the Microsoft ecosystem. I can mention, for example, Fable, that is a transpiler between F Sharp and JavaScript. And this project in particular allowed to write complete application from the browser to the web server completely in only one language, in this case, F Sharp. And this drove the community toward a varied and rich ecosystem, of course. With the version 4.0 and 5.0 between 2018 and 2020, F Sharp had a continuous evolution and innovation in the language, and all those innovation has been inspirational for other language in the .NET platform, and not only in the .NET platform. For example, I can mention C# and TypeScript. And quite often, the innovation introduced in F Sharp appeared first in F Sharp, and some year later in programming language, specifically object-oriented, like C Sharp, particularly, of course, the functional features and the transformation. And F Sharp, in some way, helped the transformation of C Sharp from a language completely imperative and object-oriented in a language more functional, so to speak. The language features of F Sharp, I try to mention the feature I think that are pretty interesting in the language. And of course, that first the functional programming language F Sharp is a functional first programming language. This means that you can program in a functional style, but you are allowed to program also in an object-oriented style or imperative style. This is discouraged by the ergonomics of the language, but is allowed. And this is very useful when you have to interact with other languages in the .NET ecosystem. The immutability by default is another feature I like in any language, to be honest. The algebraic data types, the type inference, the pipes, pattern match, the computation expression, data providers, the first class concurrency primitives implemented via computation expressions. The pragmatism of the language. This means that you can write something in F sharp in a very pragmatic way. You can solve any type of problem in a very pragmatic, synthetic, and a good way from my point of view. And the first class interoperability with other .NET languages and libraries, of course, is a plus of the language. Talking about the algebraic data types embedded in the language, we have some product types and generics, and we can use all these features of the type system to define domain data structure, complex domain data structure, combine these simple data types to achieve and represent complex data structure. This allows a principled way to model domain objects, and if this structure is well architected, can lead to have unrepresentable invalid domain states that are not valid in the domain, not representable in your program. And this, of course, is a huge benefit on the correctness of the entire application. Here we have some example of product types, generics. Type A, for example, is a tuple. Type B is a record type. Type C is a discriminated union. We have an enum, and we have generics, generic discriminated unit as type E. Then we have pipes. The pipe we as Elixir programming language lover know what pipes means, and whoever wrote something in the shell know what pipe means. But the pipes implemented the way F sharp implemented the F sharp, it was what inspired Josep Alim and his team to create the Elixir pipe as it is. The pipe, of course, allows, like in Elixir, to compose several functions with compatible input and output in a single and concise, elegant expression. The difference between Elixir and F sharp is that F sharp populate they have the same syntax, but F sharp populate the last argument. Instead, Elixir populate the first argument of the piped function. Type inference. F sharp is a strongly typed language, but when you write code in F sharp, it seems like you are programming a dynamic language. In F sharp, usually, when you develop something, you don't need to use the type definition because the compiler infers the types for you. This helps the conciseness, and the developer feels like is developing with a dynamic language, but with the compile time check. This is made possible by a strong type system. To be honest, this type system is not as strong and powerful as the Haskell one, but for sure the strongest in the .NET ecosystem. the mix between the algebraic data types and the type inference, in my opinion, is a match made in heaven, because for the correctness of any program you write in F#. The developer can concentrate on the domain logic, trying, as I told, make unrepresentable a domain state or structure that is incorrect. And the F# compiler will type check, and the type inference will help to guarantee the correctness. These happen without the need of a complex type declaration that is very often present in other type of programming languages. In Elixir and in Erlang, we don't use defensive programming, but with F#, in my opinion, you can do defensive programming, but you can make it fun and easy to program. Another feature I like a lot about F# is the computation expression. A computation expression, what is underneath a computation expression is a lot of theory, but now I want to concentrate on what the computation expression is trying to solve. In general, you can think about computation expression like a syntactic sugar to compose in a readable and understandable way several computation that depends on each other results and are also on a specific context. We can call it effect. In the example we can see in the slide, we have an example, a simple example, a trivial example, where we can try to get three numbers and to get the sum of the three numbers from the console. Of course, when we get something from the console, we can get numbers, but we can also get strings, or we can get an error in some way. So we need to use the optional type, an optional type. And when we want to represent this sum of three elements without the computation expression, we need to nest several match that get each number, and at the end of the nesting function, we can do the sum. As you can see, with the computation expression and the machinery beneath the computation expression, you can express the same program in a more readable and understandable way. You can understand exactly what is happening by these three lines of code, what we have on the right of the example. And then I want to show you what the computation expression in. I want to show you some code about this computation expression. I want to share you my other window.
Yes, Pietro, your camera is kind of, yes, better.
Okay. Okay. I'm trying to open my code. I'm sorry, just a second. Okay.
That's okay.
Okay. Here is the program I showed you in the example, but I want to start the program to show you what happened underneath. Okay, now the program is asking me to insert an integer, another, and another. And this is with the computation expression. The result is the same. If I run the program and something went wrong, for example, I insert here, the result is known because something happened, and the optionality effect pop in. And here you can see that we have the same behavior. And this type of behavior is implemented with the computation expression. The machinery underneath the computation expression is simply the implementation of a type with three members: the bind, the delay, and the return. So anyone can implement a computation expression simply implementing this bind, delay, and return. And you have at your disposition this type of this type of code that you can express, and you can express the optionality of these computations directly in this context, the context of maybe, and it is pretty clear now what this code do. It can be more tricky to understand what this code is the same code, is the same, solve the same problem, but can be quite tricky to understand if you think about something more complex. You can understand how this type of expression can be quite useful. Okay, and that's it. And I want to.
Oh, you have one more slide, right?
Yes. If I can try, if I can.
Yes,
find.
Google Meet is not the best for switching between screens. It's kind of slow.
Okay. And again. And I want to thank you, and I hope I can continue this exploration of the language. I'm not an expert on the F# programming language, but hopefully I would like to become an expert in Elixir and in F#, and I would like to expand this presentation with all the features I think that are very interesting in the languages. Thanks a lot. If you have any question.
Yes, thank you very much. I'm going to ask everyone here if they have any questions. If they don't, I have at least two.
Okay.
Oh, okay. Can you share your code screen again?
Yes. Maybe. Share. Can you see the code?
Yes. So okay. First, could you show me the definition? Because let add three numbers. Are you defining a function there?
Yes, this is the definition of a function.
It's a zero-array function, no parameters?
Yes, zero-arity. This is a function that add three numbers that we get in the console, get num. This is another function. So I get the number in the console, and everything can happen when I get something in the console, but I can get something from a database or from a network drive or anywhere. So what I want to highlight is there is something that as an optional result. Optional result, I mean, it can be an int in this case, but it can also be none if, for example, I insert an A. So I can parse the message in the getNum and decide when the input is correct. And okay, if it's correct, I have a pattern match here. If getNum is a number is greater than 0 and less or equal than 100, I return sum of n. In this case, if getNum 1 is a number between 0 and 100, I match this one. Then I get the second number. And if the second number is correct, is a correct number for my business logic, I get this one, this path. I get the third number, and I get this path, and now I have all the three numbers I needed to add three numbers. So
okay, but my question is first, this sum, is this a kind of a type?
yes, is a predefined type of F# that represent the option. An option can be sum of x, sum of 1, for example, or none. So you represent the optionality. It's a monad. You represent the optionality with a type.
To use, in order to use pattern matching, I have always to use this match something with something else.
Yes.
I cannot use pattern matching in function definitions as in Elixir and Erlang.
Unfortunately, no, not.
And
You can't
and
use.
and pipe is the pipe symbol,
The
right?
pipe,
Not
the pipe symbol is the same of Elixir. Here we don't have pipe symbols in this program, but this is the function, is the match. It represent this part represent the expression when I pattern match some y.
okay. So
This is the part
the
where some
the Linux pipe symbol is used in this code on line 22
this is
for
OR.
the match operator.
This is only the match operator. This is like an OR. Some X or known.
Can you show us an example of the pipe symbol being used in F# for the repo, for the console, in the console?
Okay, let's try.
With a predefined function.
So net terminal.
Yes, Mateus saying that syntax came from OCaml, and
yes, is as I told in the presentation, F# is OCaml in .NET with some plus like computation expression and some other feature, but essentially is OCaml. I don't remember how to run the maybe
a repo.
Yes. Just okay. Essentially, the function, the pipe works like this. Maybe okay. I define the function and let add one. X equal x plus 1. I want to highlight here that the type inference is pretty neat because it understands that add one as an input, an input in an integer, and returns an integer as output, and it's quite interesting how the type inference works.
Okay, so can you, yes. Can you
Okay.
now do one, add the one, add one, add one, add one?
Okay, one and pipe. Okay, it works exactly like the Elixir one. So, but the only difference between the two is that the argument that is populated is the last, not the first.
Yes, can you do it for one, pipe, add one, pipe, add one, pipe, add one, 3 times?
Yes.
you have always to add
one.
the semicolon, two semicolons.
Yes, in the yes, this is not so useful, but yes, that one.
Okay.
Is exactly the same.
Yes. No, not. I would say it's not exactly because it doesn't return for. It returns vol it int for. It has more information.
Oh, okay, okay, but to use in the software, you have to use exactly the same way that you use in the Elixir language.
Yes.
Osevalim made a statement when he declared that he was inspired with his team by the F# pipe.
Okay, that's great. Okay, any more question? No. So let me finish this recording.